This conference will now be recorded.
What's today's session? So in the last session, we were discuss about packages in Python, and today I'm going to discuss about two simple concepts, that is decorators and generators concept in Python. So what is decorator and how to work with them, and also at the same time what is generator, how to work with them, we'll discuss. These two topics will complete in today's session, decorators and generators. First of all, what is decorator? We have already seen in the previous examples, especially in object-oriented programming, some decorators, that is built-in decorators. Data of abstract method decorator. If you want to make the method as abstract method, we use this decorator. At the rate of static method decorator. To make a method as static, we use this decorator. At the rate of class method decorator, these decorators are for making class method only. But these are all built-in decorator methods. These are built-in only, not user-defined. So by default, Python is having some decorators at the rate of abstract method, at the rate of static method, at the rate of class method. But ultimately, how we can recognize decorator means decorator name always starts with at the rate symbol. So in Python, wherever you observe decorators at the rate symbol, that is completely decorator only, we can say it at the rate symbol. Decorator only. But we are talking today not about this uh, built-in decorators. I'm talking about user-defined decorators now. I'm talking about what? User-defined decorator. User-defined decorator means we need to prepare our own decorator and then we have to use it. How to use the decorator here. Okay, let's see this. So what is decorator means? A decorator is a design pattern. Okay, a decorator is what actually? It's a design pattern. Decorator. Decorator means in simple terminology we can say to decorate something or existing function. Already once we have a function or method which is having already some task, but without to disturb the existing task of the function or without modifying the changes in that function directly, we are just adding some decorator to that function only. This is called decorator, we can say. Okay, without adding, without existing functionality, without disturbing the existing functionality, then we are adding some extra functionality to that. So that is decorator through it's possible. So that is decorator through only it is possible. Let's see this what exactly how decorator will work. I'm saying decorator is a design pattern. A decorator is a design pattern. Yes, it is a design pattern. Okay, that allows a user to add new functionality, but allows user new functionality, new functionality, new functionality to an existing to an existing object or to an existing function without modifying its structure, without modifying it, without modifying it. Decorator is a design pattern that allows a user add new functionality to an existing function without modifying it. Means already once we have a function, that function is having some task, without modifying it, without changes that function logic, we can add some more function logic to the existing function only. That is called decorator. Okay, so decorator is a function which can take another function as an argument and extend its functionality and returns the modified function with extended functionality. So the main objective of decorator function is we can extend the functionality. This is the main object. The main objective of decorator is we can extend we can extend the functionality of we can extend the functionality of existing function we can extend the functionality of existing function without without modify that function without modifies that function. I can say that this is exactly decorator, sir. We should not disturb the existing functionality code, and additionally we can add some more functionality to that function. Then that is possible with decorator. So this is completely decorator story. Let's consider the example. These are simple topic, it's not a big deal. Wherever you want you can add the decorators clearly. Now let me take an example here. Let us consider a function called f1 is there. F1 function is having some name parameter here. The moment when I call this f1 function, I can say hello, some name, and I can say that good morning like this. And I'm calling this function with name what Sai, and I'm calling with the name what actually Mohan. So the moment when I call this function with passing the name called Sai and Mohan, okay, because this function is expecting some name parameter. When we have a function with parameter, you must and should supply parameter values, input values. So hello Sai, good morning. Hello Mohan, good morning is coming. That's fine. So this function will display the same output for every name. Okay, this function is going to display the same output for every name. But my requirement is when I supply the value for this function, the name is called Durga, for example, I should say hello Durga, good evening, I have to change. Somehow logic I want to change when we pass the name Durga to this f1 function here. What I have to pass? Hello Durga, good evening, I have to say that. Got it? So f1 function, whenever we call with the name Durga, then I can say that hello Durga, good evening only I should say that. So def f1 of name, so f1 of Durga only. So hello Durga, good evening is available. But it doesn't mean that we are changing that good evening like this without modifying this existing functional logic. If I go and change this here in place of good morning, good evening means this function again will return for every name good evening only, no? But my requirement is not like that. Only for Durga I should say good evening, and remaining persons I should say still good morning. Means modification I want to do. In that context, what we can do? So we can apply the decorator on this function. Decorator means we need to create our own decorator function. We can write the logic when name is coming to that function Durga, we should say good evening. We can add them some decorator to this existing function like this without modifying its structure. But decorators are higher order functions. Higher order function means what? General scenario. Here we are applying decorators on which function? F1 function. Means decorator function we should create after creating f1 function or before creating f1 function. Obviously before creating f1 function only, no? Yes. Decorators we have to use before creating f1 function only, we have to create the decorator function. Once you are ready with the decorator function, and that function we can attach to this f1 function decorator through. But after creating your main logic function, if you create decorator, there is no use, because these are higher order function. Before your target function only, you should ready with your decorator. So I'm saying decorator is a function. Let's create one function called decorator with the name decor, but make sure that this name is not mandatory. You can take any name it as per your requirement. The names all you can take it as your wish. Def decor decorator is there. Decorator is a function which can take other function as an argument. I'm taking this function as an argument because on this function only we have to modify Now inside this decorator function, I'm taking one more function like with name inner function. Inner function is the replication of this target function. So how this target function is having parameter, inner function also is having same parameter like name. And the moment whenever inner function will execute against to this what we can say fun function replication, then here we have to check if name equal to durga Durga. Then I can say here simply hello Durga, good evening, good evening. Else block I'm taking. In else block, same function logic only I have to call with same name. So this return function, inner function logic should return to decorator function return inner. That's it. We have to return. We have to use return keyword return inner only. So we are ready with what decorator function now. What is our decorator function, sir? This is what is that? This is the decorator function DECOR. But did I apply this DECOR function on our target function like F1? No. If it is no means, so F1 function directly will call here Sai, hello Sai, good morning, hello Mohan, good morning, hello Durga, good morning. Same result will come. You don't apply decorator, no? That's what you will get. Same results are. There is no change. But our requirement is what? When the name of the person is Durga, I can say hello Durga, good evening, not good morning. No. Yes, that's what I can do. So I have already written some decorator function. This is what decorator function names are. You can name it any name. Decorator is a function. Yes, it is a function which can take a function as an argument. Yes, F1 function is taking as an argument or parameter. Okay. Extend its functionality. Yes, F1 function functionality is extension. What function? Through inner function through by taking name. If name equal to Durga, I can extend the functionality hello Durga, good evening. And returns modified function with extended functionality. Once modified function value is there, it will return this inner function to decorator. With extended functionality, it return the modified function. So these are all by using this decorator function only. But we have not added this decorator function to this F1 function. Normally, how we can make any method as abstract method on the top of the method by using symbol abstract method we have to use. Generally, how we can make the method as static method on the top of the method by using symbol static method decorator we have to use. Same way you have to use what's are here of DECOR. It is our own decorator. Yes. Now this time this decorator logic can be applicable on F1 function. So now this time we will get when the name is Durga, hello Durga, good evening is going to display. So the meaning is what? You are ready with the decorator with your own logic, but do you want to apply this decorator on this F1 function? Compulsory we have to apply this decorator on this F1 by using symbol only. If you don't use this one, or if you don't add this one to this F1 function, then decorator logic will not work. Now this time you can see without to disturb the existing function logic, just explicitly I have added some more logic with extension. Now this logic is impacting on our method. Now hello Durga, good evening is there. But remaining persons, hello Sai, good morning, hello Mohan, good morning. But this one is hello Durga, good evening only there. Got my point? Yes, this is exactly what we are doing, sir. Hello Sai, good morning, hello Mohan, good morning, hello Durga, good evening, like this. So only Durga name is there, then I want to say that good evening, but it doesn't mean that I'm just changing directly the function logic here, good evening only. No, I'm explicitly doing this one. If you don't want to modify that explicitly, you can remove the decorator just. If you don't want to work with the decorator, remove that decorator, then as it is your function logic will work. If in case if you want to apply any decorator which is already available with you, then that decorator we can apply on the required function. This is also kind of overloading. Generally, in my previous lecture, the method overloading that was not happen because in Python programming, when we have multiple methods with same name with the different logics, but last method only will be considered no. So that means we can't make same method through multiple tasks, but decorator through we can make the same method with multiple tasks. So same method through I'm using different task results. Hello Sai, good morning Mohan, and Durga is evening different implementation because of we are added explicitly decorator function like this. So now this time you can see how decorator function will work. You can observe. First, let me keep the breakpoint here, and here also I'm going to keep the breakpoint. Here also I'm keeping the breakpoint. Okay, so now let's execute this completely here with the logic, and also I'm going to keeping the breakpoint here everywhere so that you will get clarity how it will run. First, the moment when I run this debug window will start. Once debugger window started, now start the execution by hitting what's our function key plus F8. Function key plus F8. First here you can see decorator is there. Decorator declaration is there, no? Yes, declaration. First it will be initialize. Function key plus F8, decorator is also there. Now we are calling the F1 function also initialization. It is expecting the calling place. Calling place means where it will go. Decorator is there again. Now inner function is also taking. So inner function is taking what actually name. So this name is it is going to be directly jump into return inner function. But where it will return to the decorator. But decorator when it will call whenever you call F1 function. Now you can say F1 function I am calling with name Sai. Immediately it will go to inner function. So name is available here on this name is Sai. Immediately this name is Sai is equal to Durga. No, false. False means what? Immediately same function logic will work, else block will execute F1 of name Sai. It will go to F1 of Sai. Then next Mohan, and name is Mohan. Mohan equal to Durga, not correct. It will go to else block. F1 function only will call. And F1 equal to Durga. Now you can see Durga equal to Durga is correct only, no? Correct means it will execute what, sir? This code. Now immediately Durga function will call. Everything is coming. Hello, good Sai, good morning. Hello, Mohan, good morning. Hello, Durga, good evening. So explicitly we have added the logic. At that logic, decorator logic, we are assigning to this F1 function here. In case if you want to work with same function with multiple tasks, then we can apply this decorator concept on this F1 function. Okay, like this. Sir, we are going to work with sometimes what will happen, we can call same function like F1 function with the decorator, without a decorator also. So you may get doubt. Decorator means compulsory. This decorator function we should add @ symbol through only. No. See here, I am not going to use @ symbol. No need to declare this decorator always by using @ symbol on the top of the program. You can also call the decorator without decorator. That means we need to create object for decorator function. Now you can see d equals to we are creating object for decorator function decor of F1 function. Yes, we are applying this decorator logic on F1 function only, no? Yes. So what is D? D is the decorator object. Now this time you can see. So I'm calling this function with the decorator, without decorator. Suppose without decorator means I want to, yes, Sai, I want to say good morning Sai only. So I'm calling directly function without decorator. F1 of Mohan, I am going to call the same function only, hello Mohan, good morning only. But whenever the moment Durga, I need to work with decorator, no? So decorator means you should not call F1. We should call what? D of Durga. D means what is actually decorator object. The moment when I go for D object for Durga calling, so it will go for decorator object. So decorator through we are getting now. Okay, so that meaning is what I mean to say. Decorator means always no need to use this decorator on the top of the function like this. Instead of using this one, you can create a one object for decorator function. One object means D is an object. The moment when we assign a function to the variable, this is called object only. This D equal to decorator. Decorator we should apply on which function? F1 only. When we call the function with the D parameter, so that is decorator through. This is decorator calling, sir. This is decorator calling. Decorator calling. This is without a decorator calling. With a decorator, without a decorator. This is F1 we are using. Got my point? Even if I try to F1 here also, then what will happen? No decorator we are applying, no? So that means you will get what? Same result. Hello Durga, good morning. Hello Mohan, good morning, like this. If I use this one now, then now this time you can see decorator calling. Now you can see decorator calling through we are working now. So decorator means always no need to apply on the top of the program like by using a @ symbol. This also we can able to use it. So this is decorator object we can call it as. Okay. So like this we can do. And one more example I'll tell you with the decorator again. So any logic you can write by using decorator. DEC1. For this program now, I have a function called division function a comma b, and I'm trying to print. Okay, so just in this division function, I'm trying to print a by b. The moment when I call this division function, now I'm taking actually here 2 comma 4. I'm taking, for example, 2 comma 4. That meaning is what? A simple division function which we have, and in this two parameters are there a comma b, and print a by b is there here. A by means 2 by 4 only. When I run this, now you can see we got the output here 0.5, because 2 divided by 4 is 0.5 only is there. Division of 2 comma 4 here. Division of 2 comma 4. This is the case. 2 by 4 0.5. But my requirement is what? My condition is if first number less than second number. If a less than b, then I want to swap the numbers. Swap the numbers means a value should become b, b value should become a. Means 2 become 4, 4 become 2 only. Swapping the numbers. Only the condition whenever I reach 2 less than 4. Means 2 less than 4 is correct only. A less than b. In that context only I need to change the values. Means swapping the numbers. So how we can do means just decorator through we can do it. So let's say decorator. I'm taking decorator def, and my due is my decorator function. Decorator is a function which will take other function as an argument, and here I'm taking inner function. It's a replication of main function which is having ab, and here I'm passing the condition if a less than b, then what I can say a comma b equals to b comma a, swapping the numbers. So b will be assigned to a and a will be assigned to b only. This is swapping. Else if not, okay, if first number smaller than second number not, then else part only how to execute. Else not, directly we have to return division function only. Even else also we can write. So now we can see return div function of a comma b. Same logic I have to work. Finally I want to return inner function to my div only. Now you can see here return my div. So this is the my div logic is going to be written. Sorry, return inner function is there. So what I mean to say here, if my logic is div 2 comma 4, right now just me call this 2 comma 4, no? So suppose 6 comma 3 is there, 6 comma 3. Right now what is happening? 2 by 4 and 6 by 3. Yes or no? 2 by 4 means 0.5, 6 by 3 means 2.0. This is 2.0 and this is 2 by 4 only. Yes. But my condition is what I have written in the decorator through. If a less than b means first number smaller than second number, Then swap the numbers. I'm saying swap the numbers means a value become b when b value become a only, otherwise not. But in the first case 2 comma 2 4 is there, 2 less than 4 or not? Yes, correct. Correct means now this time a will become 4, b will become 2. That means 4 by 2 will come. 4 by 2 in the sense 2 only. But here second case 6 comma 3, 6 less than 3, correct? No, correct. No, correct means same as it is 6 by 3 only it will be there. But we have to apply this decorator. How to apply the decorator means at the rate symbol through we have to use myDiv. That's all. The moment when I apply this myDiv decorator on this div function, now you can see the result is two cases 4 only. Actually a by b, first number division by second number. If it is 2 by 4 means 0.5 should come, but why 2.0 coming? Because values are interchanged, means swapping. If the decorator through I'm changing. So if 2 less than 4 correct means, so a value will become b, b value will become a. If 6 comma 3 means what? 2.0. 6 comma 3 means 6 less than 3. Not correct. So if not correct, what will happen? Same logic. 6 by 3 only will be there. 2.0 like this. So this is explicitly we are preparing the function. That function we are assigning onto the decorator logic. This decorator logic I'm using. If you don't want to apply decorator logic, you can remove this. Same logic will come. 2 by 4 means 0.5. 6 by 3 means 2.0 like this. So this is about ultimately decorator concept here. Decorate something, add something to the existing function without modifying over it. Without modifying means it doesn't make sense here b by a. I want to go for 4 by 2 means not doing the modification like b by a. Okay. Without existing, without modifying the existing functionality of the function behavior. Additionally, we are preparing the logic according to your requirement. That logic we can inject to the existing function. This is nothing but what actually decorator. It's a design pattern. We can design that allows a user add new functionality to existing function without modifying the main function. The main objective of decorator is we can extend the functionality of existing function without modifies that function, we can say that. So this is about decorator. Next, another simple topic is there in Python, that is called what? Generator. What is generator? Yes. See, generator general meaning is what? To generate something. Observe. So to generate something. What something? Generator is used to generate sequence of numbers. Okay. Generator is used to generate sequence of numbers. It is used to generate sequence of numbers. So first I want to tell you generator versus normal collection. Normal collection how it will be and generator collection how it will be. I want to show you the example first. Then only you can understand the clear logic how generator and decorate how generators will work in Python. Okay, let's see this how it will be. So is a generator is used to generate values, sequence of values. But I want to say first normal collection and generator collection differences. Then after that I'll try to work with generator function. Python provides a generator to create our own iterator function. Generator is a special type of function which does not return a single value. Instead of, generator returns an iterator object with sequence of values. Iterator object means multiple values are there with that object, and we can able to sequence of values. We can able to generate all the sequence values. Generator function is defined like a normal function, but whenever it needs to generate the value inside the function yield keyword, it can be used. Yield, yield, it's a keyword in Python. If you check in the keyword list, there is a yield keyword also there, one of the keyword, rather than return statement. A generator function is defined like normal function, but whenever it needs to generate the value, and the generator function will do generators with yield keyword only rather than return statement or any function. So I'll tell you the generator function how it will be. First, you can try to understand this program. It's a normal collection, sir. It's not a generator collection. Normal collection and generator collection, you just try to observe. I'm taking list object here normally. L equals to. Okay. So list object. It is list comprehension. List comprehension means within the list we can able to iterate for x in range of n. Suppose. So here I'm trying to print L. Just try to observe this. What is the type of L, sir? So this is the list comprehension. List comprehension means within the list we are going to apply the loop condition for x in range, and we are returning within the list only one of the value, x value. So we are returning this range of values to the x we are printing here. The moment when I try to run this code, so you'll be able to print this, okay, all the values 0 to 9. But what is the type of L type? List type. Okay, list type. So this list type is okay, but I want to print this values in the iteration wise. Iteration wise means what? For I in L. L is holding values, print I, and I want to print these values into some space here. For I in L, print I and the attribute I'm using. Now let's run this. We are iterating 1, 2, 0, 1, 2, 3, 9 values. It's a type is list type, observe carefully. But when I try to give 100 values, yes, it will work, sir. 100 values working. When I try to give 1000 values are generating. When I try to give 10,000 values, 10,000 values are generating. If I give this 1 lakh, 1 lakh values are generating. If I give 10 lakhs, 10 lakhs values are generating. Okay. But the problem is what this example. Okay. If I do like this, this is completely huge number of values. No? So obviously you will get memory error. There are two possibilities are there. For your kind information, I'm not going to execute this logic. I know that very well what's going to happen when I execute this logic, because two things are possible here. Either I should restart my computer because of hanging, or else after waiting long time, I will get the memory error in red color, memory error in the output. But just try with after completion of class, you can take the same example code and try to apply in your computer. You just wait what is going to happen. But for sure that it will not work out here in this case. But I'm not going to execute. Why? Because if I execute, I need to stop the session and restart the session or restart the meeting. So because of huge values are taking no here in the normal collection, we will get memory error, or after waiting long period and you should restart your computer. So anyone, its possibility is there with this example now, especially normally 100, 200, or 1 lakh, 10 lakh values within the limit range, it's possible, but we are using lakhs of crores of values here. So we will get memory error in this case, because all these values are required to stored in the memory first. Okay, all these values are required to store in the memory first only. After storing all these required values in the memory first, then it will iterate the values, but this will give memory error, so no doubt at all. So to avoid this issue, what I can go, generator collection I can go, sir. Generator is required now instead of normal list iteration. Let's see this 10, because I need to show you generator. Just I'm changing little modification. Now you can see instead of list in square bracket, I'm taking round bracket. Round bracket means it doesn't mean the tuple. No, it's a generator type. You can see type of L, previously it was list. Now this type of L, now this time what actually try to understand? Generator. Now this time you can see this, I can literally run this values, no problem. There is no problem at all here. I can run it. There is no hang, there is no memory error, because it's a generator type. Generator type is used to generate values, keep on. It's very good. So what will happen in this case, in the generator case? In the generator case, we will not get any memory error. We will don't get any issue at all. because all these values are not stored in the memory at the beginning. Okay, in the memory at the beginning. So that's what generators are best suitable for reading data from large files. Suppose whenever we have huge number of records are there, we don't expect how many records are there. The huge number records, huge number collection is there. Then how we can iterate them one by one? In the sense, better to go for generator collection instead of normal collection. If we go for normal collection, when we have lakhs of crores of values, then the problem is what? Actually there is a problem called memory issue. And to avoid this issue, normally when we have huge number of iterations or collections, better to go for generator collection. Generator is used to generate the values. Okay, so without fail, there is no memory is required in the first. So automatically it's keep on generate the values clearly here. Okay, so it's not permanently saved the data. Obviously, it's a temporary memory only, because permanent storage is what? We have to go for either file handling or we can go for database handling. No, we already discussed that. So you're not going to store. If you are going to with the database handling, this memory is there database. Obviously, this values will stored in the file or database. Okay, right now in this case, we are not storing the values. So that's what generator is the best for iterating the values. Means database is having huge records. We are iterating them one by one to read the values. Then generator says the best option. See this, it's keep on iterating. We are not going to stop. This is keep on working fine. But whenever the moment when we go for normal list iterations, that is a memory issues will be raised. So I'm just stopping debugging in the middle. It's not required. Just I want to show you the difference between what? Normal list iteration, normal generator iteration. List iteration means this one not work with huge number of values. Even if you try in your computer, and after that you will wait, memory error will come. If I, this is type of L is list only. If the moment when I change this now brackets, now this time you can see this, it's going to be generator actually here. This is generator. Okay. Yes, we can use generator instead of normal list collection. When it is generator is required means whenever you have huge number of iterations. Normal maximum range also we can do with list iteration, not a problem. But sometimes we can have that huge number. So we don't know exactly how many number of collection values in the database or else. Then better to go for generator. Now coming to the generator function. This is just an example, the difference between normal iteration and generator iteration. Now we'll go for generator function. Python provides generator to create our own iterators. A generator is a special type of function which does not return a single value. Instead of it returns an iterator object which is the sequence of values. In generator function, a yield statement is used rather than a return statement. Normally, generator function means how to recognize. Simple. If the function body, suppose this is the function body, generally we can take inside the function body what it will take, print or return. Suppose here you can see this time I'm taking this function. Inside the function body I'm using print function. No? Yes. Or else sometimes inside the function body I can use return statement. Return means yes, it will return the value what you are expecting, hello. So returning the value, no, that's what I'm printing here only. Now this time what will happen? It's same result we are getting. So normally just observe inside the function body either you can use print function or you can use return keyword. This is called actually normal function. But whenever the function body, definition of the function body contains yield keyword, okay, yield keyword, then this means what? Actually it is a generator function, it's not a normal function. Now you can see it return yield, but here yield will return only, but we are not printing here. Print f1 function I'm taking. The moment whenever I print f1 function, but look at this, what's happening here? Just observe carefully, it's a generator object now. Got my point? Previously whenever comment this, and now you can see here I'm returning return statement, I'm using return statement. Function is returning what's our value. We are printing that f1 function calling. But f1 function is not, it's a normal function. Normal function will return the value hello, but you can stop this one and you can activate this one yield keyword. So this is a generator function now. How to recognize a simple logic? Inside the function body, whenever you observe the return statement or else print function, that is a normal function. Or inside the function body or inside the DEF, when we observe the yield statement or yield keyword, it's a keyword, then this is not a normal function, it's a generator function, and it return generator object only. The moment when I go for print f1 object, now you can see it's coming hello. No, what is coming here? Generator object f1 at this memory. So that means what I'm saying, a generator is a special type of function, yes, which does not return a single value, don't return single value. Instead of it return an iterator object. So it is iterator object is returning with sequence of values, lot of sequence of values, any sequence of values you can use. For example, yield hello, hi is I'm returning, and yield okay welcome I'm returning, like this. So right now f1 is having iterator object. So if you want to collect these values from the f1, then you can iterate that. How to iterate that? For I in f1, f1 is a generator object. From that f1 collection I'm iterating one by one for I in f1. So we got this values now this time because it's a collection. It return with yield keyword rather than return statement. So hope you understand this. Generator function means how to recognize. If the function body contains yield keyword, that is called generator function. If the function body don't have yield keyword, means return statement is there or print statement is there, that is a normal function. Generator function will return the object with iterating the values. So this object through we are iterating the values one by one for loop through here. Or else instead of for loop, we can also use generator object also. Generator object means apply, whenever we assign this generator function to the variable like g equals to mean something. So g is nothing but generator object because we are assigning this generator function to the object called or variable called g. G is called generator object, and from the g collection also we can do for I in g. So now you can see hello I welcome. Excuse me. Now print g and print type of g. What is there? You can see this type of g. So g is nothing but generator object, and g type is what actually generator type. In the G, we are going to be yield keyword through G collection, generator collection. It is G represent generator object. You can take it any name it, and F1 function is assigning to the variable called G, that is generator object. From that generator object, we are calling this values one by one. Or else we have one more option instead of this one. So here G is a generator object. No? From this object also one by one, if you want not all the values, only few values, if you want first few values, then simply we can go for g dot underscore underscore next function also we can use. Print g dot underscore underscore next function one by one as per your requirement. Print g dot underscore underscore next function also you can use. This will also work. Or else we have one more option is there, next of g also, instead of g dot next of g, and also here next of g. Again here you can see this next of g, or else g dot next also we can use. This is about generator iteration. So what is the yield? Yield means it's a keyword. So what is the benefit of yield, sir? So yield is a keyword in Python. If we go and check out in the keyword list, there is an yield keyword is there that is used to return from generator function without destroying the state of its local variable. Means the state will not be destroyed, still it is there when the function is called. The execution start from the last yield statement only. Whenever we recall the function, execution will call the last yield statement, whatever the values are there here. any function that contains yield keyword that is termed as a generator only. That means yield keyword advantage is what? Normally, if I don't use yield keyword, return statement or print statement, when we call this f1 function, that return statement or print statement will execute. After completion of executing this f1 function, the return statement, print statement, local variables will be destroyed from the memory. It will not be stay back. Again, whenever you recall the function, that print function and the return statement will recall it. But in the generator function, not like that. If I use yield keyword, then this local state will not be destroyed from the memory. Even though when we exit from the function, whenever you recall the function, that values only will be stored here. Yield keyword through no, it return that values only, it without reconnecting the values from the memory. That is the speciality of yield keyword like this. So this is generators and decorators. How do we recognize a function called generator function? Means simple, inside the function body when we use yield keyword. If the inside the function body there is no yield keyword, normal print function and return statement is there, that is a normal function. It's not a generator function. This is about generator decorator concept in today's session. In the next session, we'll discuss two more simple concepts like assertion and logging. After that, pandas and matplotlib. Then we'll go for next. We'll go for Django. I'll tell you the date also. Date I have already announced. That is 27th February, Monday, morning 6:30. Django sessions are going to be start. And next week I have to complete this one completely, all remaining topics which we have. And the next session will be on Monday, and the new link I will send tomorrow Sunday night. You just wait for the new link. This link will expire today only. Again we'll send a new link. That link will work for continuation. See you on Monday.